Hello friends, welcome to our lectures today. On our lectures today, we're going to be studying electric charges and the Coulomb's law. Electric charges and the Coulomb's law. Now, what are electric charges? Electric charges can be defined as the quantity of electricity on a body. Electric charges can be defined as the quantity of electricity on a body. What then would be the Coulomb's law? The Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the magnitude of the charges and inversely proportional to the square of their distance apart. Coulomb's law, I repeat, states that the force of attraction or repulsion between two charges is directly proportional to the magnitude of the charges and inversely proportional to the square of their distance apart. How true, how true. Now, assuming we have two charges, a positive charge and a negative charge. Let's call this Q1, and let's call this Q2, separated by a distance arrow. Now, this would give us that Coulomb's law states that the force is directly proportional to Q1 times Q2, and Coulomb's law states that the force is inversely proportional to 1 over r square. This would be what Coulomb's law would be stating. Now, combining this, we have that the force is proportional to Q1, Q2, all over r square, How true? Very true. Now, in eliminating the sign of proportionality now, we have to introduce a constant, right? We do that by introducing a constant, and this would be equal to K Q1 Q2 all over r square. So this would be that F equal to K Q1 Q2 all over r square. This would be the formula to calculate the force between two charges separated by a distance. Now, this K is not just any random K now, right? This K has been given a mathematical value of 1 over 4 pi epsilon naught. This K has been assigned a mathematical value of 1 over 4 pi epsilon naught, and the value gives us 9.0 times 10 raised to power 9, and the units would be Newton meter square Coulomb inverse square. How true. Why E naught now stands for permittivity of free space. E naught stands for permittivity of free space, permittivity of free space. That is what E naught will be, and E naught is given a value of 8.85 times 10 raised to power minus 12. That will be the value of E naught, and the unit would be Coulomb square meter Newton now, Newton inverse, and meter inverse square. That would be the unit for E naught. Now, let's solve one or two problems and let's see how it goes. Let me move the screen upward. Now, assuming two charges, a positive charge and a negative charge, right? Separated by a distance 2 meter, and this would be 3 microcoulomb, and this would be 2 microcoulomb. 2 microcoulomb. Now, how can we calculate the force of attraction between these two charges? Now, there would be an attractive force. Why? Because this is a positive charge and this is a negative charge, right? There will be an attractive force. So we can calculate this by applying the Coulomb's law formula, the formula for Coulomb's law, which states that force is equal to K Q1 Q2 over R square over R square. Now, in bringing out our data now, we have that the Q1 would be equal to 3 microcoulomb. 3 microcoulomb. That would be what Q1 would be. And to convert this microcoulomb to coulomb, we have to multiply by 10 raised to power negative 6. We can't work with microcoulomb, right? We have to work in the standard units, in the SI unit. That would be coulomb. So this gives us 3 times 10 raised to power minus 6 coulomb. How true, how true. Now, Q2 would be 2 microcoulomb. So since we can't work in microcoulomb, we must convert that microcoulomb to coulomb. So that would give us 2 times 10 raised to power minus 6 coulomb. That is what we have. That is what we have. So our distance now, arrow, is 2 meters. So we have all our variables, right? So we can proceed with our calculations. So the force now is equal to, remember that our K is equal to what? 9.0 times 10 raised to power what? 9. The unit will be Newton meter square coulomb inverse square. Coulomb inverse square. Now, our force now will be equals to K. Our formula says K Q1 Q2, right? Is equal to 9.0 times 10 raised to power 9, right? Multiplied by Q1. Q1 is 3 times 10. 3 times 10 raised to power minus 6, right? Multiplied by Q2. Q2 is 2 times 10 raised to power minus 6. All over. Now, our arrow is 2. Our arrow is 2. So the formula says we take the square of arrow. And so that will be 2 square. 2 square. 2 square. Our force now is equal to 5.4 times 10 raised to power minus 2 divided by 2 square now gives us 4. 2 square gives us 4. Now, in the end, our answer in computing these gives us 1.35 times 10 raised to power minus 2 Newton. That would be our final answer. So there you have it, guys. This is how we can illustrate and evaluate problems involving the Coulomb's law. So why don't you click on the next video? We're going to be solving more problems involving Coulomb's law, right? So thank you so very much for watching. See you in the next video. Remember, knowledge will change your life forever.